Good morning, Aurora. It is Thursday, June 3rd. We're going to continue day two of learning about the wind today. We started yesterday, Wednesday, kind of learning what wind is and some different pieces about the wind. So if you didn't get a chance to complete yesterday's assignment, please do that first before moving on to today's assignment. But today we're going to focus on there's two types of wind. You have your local versus your global wind. Now, these two things share some things in common, and they also have some differences as well. Now, today's assignment ultimately is going to be to complete a Venn diagram, placing 15 items in the right spot of the Venn diagram. And in order to do that, you should be watching this video and using this notes sheet that's provided. So let's start first with a local wind. So a local wind, we have to know, first of all, that they occur in a very small area. Okay, so local is small. They blow over short distances since they're in a small area. And they are, like all wind, caused by the unequal heating of the Earth's surface, which creates local convection currents or moving air. And as usual, with any type of wind, cooler air, high pressure, always goes towards warmer air with lower pressure. Now, these local winds often happen near large bodies of water. So, a lake, an ocean, a bay where the land meets the water. And we have what is known as either a sea or ocean breeze or a lake breeze. And that is a wind that blows from the water towards the land. And we can also have a land breeze, which blows from the land towards water. So the name of this wind, sea or land, kind of tells us where it's coming from, and then it heads to the opposite. So again, a sea breeze comes from the water and heads to the land, and a land breeze starts at the land and heads towards the water. If we continue down these local winds, land and sea breezes, we have a couple diagrams here. One is showing us daytime, what happens usually, and nighttime. Now, we're going to get into some more detail with these land and sea breezes coming up, but just to give you a little summary here, during the day, typically the land, the sand or the ground, is a lot warmer than the water is that's next to it. So, therefore, in this land area, the warm, less dense air rises, and then the colder air over the ocean, cold, denser air, sinks and kind of goes under that warm air that's rising. So we basically have a higher, cooler area over here. Okay, more pressure, higher pressure goes to the lower pressure area where the air is rising over here, and these arrows that are coming from the water to the land, this is the breeze you feel on the land, and this is called a sea or ocean breeze. It's coming from the water and heading towards the land. This typically happens in the daytime when the land is warmer than the water is. However, if we go to night, the opposite happens. The land is typically cooler than the water is. So now we have warm air rising over the water. Okay, this is a lower pressure area. And then we have that colder, more dense, higher pressure air coming in off the land towards the water. Now, in this situation, the breeze is coming from the land towards the water. This is a land breeze. So if you're on a boat in the water, you would feel the breeze coming towards you. Again, this is a local wind, these land and sea breezes, and they happen typically when there's water that meets up with the land, a decent sized body of water. You're also going to have your local breezes, kind of what you feel in your yard or in your town is a local breeze as well. But no matter if it's local or not, it's all about that unequal heating and the convection currents that are happening from a high to lower pressure area. Now we go down and we have now global winds. Okay, these are winds that are occurring over massive areas on the earth. So they now occur in a large area, the opposite of a local wind. These are a large area, and they blow steadily. They're happening all the time in specific directions over long distances. Okay, these winds blow for hundreds and thousands of miles, okay, across the Earth's surface. They're still caused by unequal heating, and now we have big global convection currents. So the same as local winds, unequal heating causes these winds are just bigger than a local wind would be. Again, cooler air, high pressure, moves towards warmer air, low pressure, just like a local wind. We actually use these global winds. If you've flown a plane or been on a ship, they have to kind of know about these global winds to kind of, figure out their course and their speed because it can affect travel. Okay, so these are massive winds. And again, they're caused by huge global convection currents. As we've learned before, the equator is always warmer than the poles. So we have these massive convection currents that are going across the globe from higher to lower pressure areas. All right, now one thing we're going to learn about as well is this thing called the Coriolis effect. Very important because the Coriolis effect curves the winds. So winds do not blow straight up and down or north and south. Instead, they curve. And that's because the Earth is rotating. It does a rotation every 24 hours. And since it's rotating, the winds curve a certain way based on that rotation. And that's going to depend upon if you live in the northern or southern hemisphere, which way they curve. We also have to take the Coriolis effect into consideration when traveling in a plane because you have to adjust for the Earth's curvature or the rotation. Now, there's some names of major global winds. Okay, now it says see diagram on page 51. Eventually we will see that, but just to expose you to the names, maybe you've heard of these before. There's trade winds, and yes, traders in the past had to kind of learn about these winds and use them when they were sailing across the Earth. We have polar easterlies that kind of start in the North and South Pole. We have ongoing prevailing westerlies, and maybe you've also heard of the jet stream as another global wind. We also have areas that have no wind. Along the equator, there's an area called the doldrums. It's pretty calm there. There's really no wind. And we have another no wind area. Now, let me correct. It's really there's there's a little bit of wind, but it's very calm, light winds. We also have the horse latitudes, which are kind of in between the poles and the equator, that also have very calm winds. But these other areas above, they're ongoing winds that travel large distances over the globe. Okay, so this is kind of, again, a rundown of local versus global winds. And whether it's local or global, they do share some things in common as well. Now, the next thing is today's assignment that I'm going to bring up right now is a Venn diagram. So just like before, we have an area where it could be both, that you could put something. We have an area that it can be just local, and we have an area that can be just global. And over here on the side, there are 15 items that you need to place into the Venn diagram. I've already created for you text boxes in each section. Of course, you can adjust the text boxes if you need to, whatever works for you. I don't mind if some of the words are kind of out of the circles a little bit, that's fine. But my suggestion is to come over here and instead to retyping all of these, I would just copy and paste them into the correct section because therefore the spelling's right, they're exactly the way they are, and you know which ones you've done and haven't done. Now there's 15 of them, and you need to figure out where they go. We should not be guessing. Okay, we should go back to the video or the attached resource to help you place these. And I'm going to basically score this out of 15 points, how many that you get correct or incorrect in the appropriate section. Okay, so please take your time with this. And if you're doing this, I sure hope that you've watched the video and are using the resource to help you. So again, we have wind, and more specifically, we have these local winds and global winds that are moving across the Earth's surface. So there's differences, and of course, we have stuff that they have in common as well. As the days go on, we are now going to move into different types of global winds and kind of looking at the land and sea breezes as well. Have a good day, Aurora.